depending on these, all the topics so far we covered, which is about the ray diagrams of the convex mirror and a concave mirror, and the image formed by these convex and concave mirrors. Now, we will see some of the important previous competitive exam papers. For example, very recent, if we take our POLYCET 2016 there, in that we are having one question like this. Okay? When a ray of light passes through principal focus of a concave mirror, then after reflection, the light ray passes, given options are like this, passes through the pole, next one passes through center of curvature, or option C, passes parallel to the principal axis, and option D, none of this, let us suppose, none. Okay. Now, given one is, when a ray of light passes through principal focus of a concave mirror, then after reflection, now we will see. Okay. Now, if you remember the rules for drawing the ray diagrams as we discussed before, now given that for this concave mirror, now the light ray, it is passing through the principal focus. Then if the light ray passes through the principal focus here, following rule 2, after reflection, the light ray actually it has to pass parallel to the principal axis here, like this. Okay. Now, the light ray which is passing through the focus after reflection from a concave mirror, it is going parallel to the principal axis here. So, in the given options, not the pass through pole, not through C, and option C, which is parallel to the principal axis, is correct. Okay, following rule 2, that is. Or for suppose, if they want to give you any of the question on this ray diagrams, now the question may be like this. By using a concave mirror, if we get an image formed between C and infinite, then size of the object is, size of the image is, given options are option A, same as object, and B, enlarged, option C, diminished, and option D, cannot say, like this. So, actually here by using a concave mirror, if we get an image which is formed in between C and infinite, that is, then what about the size of the image? If you go through the image characteristics formed by this concave mirror, actually the image formed in between C and infinite, so that the object actually it is placed in between, if you remember, that is coming in between C and F. Like this. So that the image is forming between this, if this is the object and this is the image, and that image actually we are getting in between C and infinite, that is, which means that the image formed is an enlarged image, that is forming an enlarged image. If you remember, the position of the object is nothing but the fourth ray diagram, that is, okay. So, the image formed is enlarged image, and that too very recently given 2016 paper. If you see the question there, here an object is placed between focus and pole of concave mirror, then the nature of the image formed is option A, real, inverted and same size, and B given real, erect and enlarged, and C given virtual, inverted and enlarged, and D given virtual, erect and magnified. If you see the question again, an object is placed between F and P of a concave mirror, then the nature of the image formed is, means that is about the special case of the concave mirror. Only one case it is forming the virtual image, of which when the object is placed closer to the mirror here, means like this. Object is very much closer here. This is the position of the object. Then the image formed by that is actually behind the mirror, and here we are getting the image like this, which is behind the mirror, as it is virtual and it is behind the mirror means erect, and not only that, the image formed is a magnified image we are getting. So that's why in the given options, option D is correct, which is virtual, erect and magnified, that is. Next one, another way of asking the question is, say for example, like this. Read the following statements. For suppose statement A, if you took, light ray passes through center of curvature after reflection, passes parallel to principal axis. This is the statement 1. And let us suppose statement 2. If it is given light ray incident on pole of any spherical mirror after reflection a regular reflection takes place. Means angle of incidence is equal to angle of reflection, that is. Of the given two statements, here the given options are like this. First option given A and B, both are true. And second option given only A is true. And third option given only B is true. And fourth one given both A and B are wrong, means false, like this. If you see the first statement, if the light ray passes through center of curvature after reflection, passes through the parallel to the principal axis, means if you remember the rules for ray diagrams here, now if this is a concave mirror and the light ray actually here given passing through center of curvature there, see. Then after reflection, now the light ray actually, according to the rule 3, now the light ray has to retrace back in the same path. But given is the light ray passes parallel to principal axis there, which is a wrong statement, this one. Whereas, come to the second case, if the light ray incident on pole after reflection, a regular reflection takes place, where regular reflection we are having a case that angle of incidence is equal to angle of reflection, of which this is following rule number 4, that is, when the light ray incident on the pole of a spherical mirror after reflection, here the angle of incidence and angle of reflections are same, which means our statement A is wrong, whereas the statement B is true here. So means only B is true, which is third option is correct. Now we will see, just like the spherical mirror, now we are seeing on the plane mirror about the relation between the angles, how the questions are coming. Okay. For suppose in the given diagram of which we are having a plane mirror is there, of which when the light ray incident on that plane mirror making an angle with the surface, let us suppose 25 degrees. Now after reflection, now the question is, what is the angle of deviation here? Okay, what we have to find is angle of deviation. Okay, whereas angle of deviation means here the angle of which the light ray is deviating from its path, of which you call that as angle of deviation. And how we are getting that is, if you extend our incident ray, then how much is the path the light ray is deviating, that gives you angle of deviation here. This is called angle of deviation. But it is given that here the light ray is making an angle with the surface 25 degrees here, means that is going to be our glancing angle. Then if you take the normal, then the remaining angle becomes 90 minus GI. So from this, angle of incidence becomes 90 minus glancing angle of incidence, which is 90 minus 25, which is 65 degrees, that is. If angle of incidence is 65 degrees, then this angle of reflection also becomes 65 degrees, that is. So therefore, as angle of incidence is equal to angle of reflection, that also equal to 65 degrees. Okay? Then we know that we already derived a formula that angle of deviation is equal to 180 minus 2i here. Then as angle of deviation is 180 minus 2i, then 180 into 2 into 65, that is. Then 180 minus 2 into 65, which is 130 degrees, which gives you 50 degrees. So means when the light ray incident at an angle 25 degrees with the surface on a plane mirror, after reflection, the light ray is deviated by an angle of 50 degrees here. Okay, like this. Now we will see, for suppose by using a concave mirror, if we want a parallel beam of light rays which are passing through parallel to the principal axis, how to project the light rays? Okay. So question is, by using a concave mirror, if we want a parallel beam of light rays passing parallel to the principal axis, then how to project the light rays, means how to incident the light rays on that concave mirror we want. Actually here we need a parallel beam of light rays. So means here we need to take the light rays following the rule 2, so that the light rays here, they are passing through focus. Then if you are taking the light ray passing through focus, like a diverging beam of light rays here, like this. After reflection, now the light rays are passing parallel to the principal axis here, like this. Okay, like this we are getting the light ray after reflection going parallel to the principal axis here. So that we are getting a parallel beam of light rays by using a concave mirror here. Next one we will see about one of the very important one called magnification. Okay, magnification, and its factor, it is represented with a small m, magnification factor, small m. Okay, now magnification is nothing but which gives you about the size of the image here, and magnification, its formula, m is equal to height of the image by height of the object. It is the ratio to height of the image to the height of the object. It is also equal to the image distance by object distance. Image distance means distance of the image from our spherical mirror, and object distance means distance of the object from our spherical mirror, that is. Okay, means m is equal to height of the image by height of object, and image distance is v by u. If you are forming a real image is coming, if it is a real image, then as the light rays are bouncing back into the same medium, here we are getting an inverted image is coming. To show that inverted image, we are getting the magnification m value as negative here. M is minus, we are getting that. Okay, which means here m is equal to height of the image by height of object, which is equal to minus v by u, that is. Once if it is forming a virtual image is formed, if it is a virtual image, then magnification m is equal to, we are getting a positive value we are getting. So that m is equal to height of the image by height of object, which is equal to minus of minus becomes plus, we are getting, of which m is equal to v by u we are getting. Depending on the value of the m, magnification factor, we can decide whether the size of the image is enlarged, same size or diminished. How that? Now we will see that. Okay, so if suppose the given m value, if it is less than 1, if you are getting, which means the height of the image by height of object is less than 1, which means that height of image is less than height of object, which means that is going to be, as the height of object is less, this is called diminished image. This is called diminished image. That is our first case. Second case, for suppose if you are getting the magnification factor value as m, 1 there, m is equal to 1, then height of the image by height of object is also equal to 1, then height of image is equal to height of object. Okay, whenever if height of image is equal to height of object there, which means the image formed is of same size as object, that is of same size as object. That is our second case. And third case, here we have m value which is greater than 1, means height of the image by height of object is greater than 1, that is, then height of image is greater than height of object. If the height of the image is greater than height of object, we call those images as enlarged image. That is taken as enlarged image. Okay. Now, how the questions are coming from this one, which is about magnification, is, for suppose they may ask the question like this. Depending on the size of the images there, magnification factor, if a question is given like this. If m is equal to minus 2 for a given spherical mirror image, if m is equal to minus 2, then what do you mean by that is, this minus represents that is going to be the inverted image, and 2 represents as 2 value it is greater than 1, which is about our third case. So that is going to be enlarged image, means we are getting an inverted image and an enlarged image here. Like this. Okay, have understood now how to calculate case, or how to take the case of magnification, where here m is a magnification factor which is greater than 1, less than 1, may be equal to 1. Now we will see after that magnification, now we will see about mirror formula. Mirror formula is actually 1 by f is equal to 1 by v plus 1 by u, that is. Whereas f is the focal length of the given spherical mirror, that is. Whereas u is the object distance you are taking, whereas v is the image distance. So, see that formula again, as 1 by f is equal to 1 by v plus 1 by u, where f is the focal length. Focal length is nothing but the distance between the pole and the focus here. Okay, and object distance is nothing but the distance between the mirror you are taking and to the object, that only we call that as object distance. Whereas v represents the image distance, whereas image distance is nothing but the image formed, the distance between the mirror and the image, that only we call that as image distance, that is. As we have the mirror formula is there, 1 by f is equal to 1 by v plus 1 by u, of which f, v and u, those are nothing but the distances here. These distances we are having a problem while taking the sign here. Sometimes we are having a positive one, sometimes we are having negative. So, how to take these sign conventions? So, we have to follow some rules here. Okay, that rules for sign convention, now we are seeing that. Okay, so any of the mirror, whether it is a convex or concave, mostly they are following three important rules here. Okay, for suppose if you are taking a concave mirror first, let us see for concave mirror case. Now, according to rule 1, it is about here any of the light distance you are taking, any of the distances you are measuring, either f, u or v. In all the three cases, these distances we have to measure only starting from its origin. Here origin is nothing but the pole we are taking, P. Okay. So, here if you are taking the object, okay, the distance, the object distance or the image, which means the image distance, or the focus point, which is about the focal length, all three distances we have to measure starting from the pole here. Let us suppose if you are taking the focus position for concave is here, then we have to start only starting from the pole, we have to measure the distance. This is focal length distance. And in the same way, if you are taking an object, let us suppose this is our object, then the object distance also we have to measure starting from the pole here. And not only that, the image formed here, even this also we have to take starting from the pole. This is our rule 1. Okay, see that again the rule 1. Rule 1 is any of the distance you measured, f here, object distance which is u, or the image distance which is v, all these three you have to start only from the pole of the spherical mirror, that is f, u and v. Okay. Now, the second rule is according to this rule 2, when you are taking the distance which is measured in the direction of incident ray is taken as positive. In the opposite direction of incident ray, we have to take that as negative. Okay, see that if you are taking the incident ray means nothing but the light ray which is started from the object which is going to incident on the mirror. Okay, so if you are taking that incident light ray, okay, if the distance you are measuring is in the same direction as incident ray, that distance is taken as positive here. But if you are taking that distance measured is in opposite direction, then we have to take negative. If you observe clearly here the focus, the focal length you are taking starting from the pole to the focus for concave mirror, the incident ray and the focus both are opposite to each other. So that's why for the case of concave length, concave lens here, concave mirror here, the focal length is negative. Okay, whereas the object distance if you take from the mirror to the object, here also we are measuring opposite to our incident ray. So that's why here the object distance uv is also negative. Whereas in case of v, the image distance which is formed on the same side, here the image distance also we are measuring opposite to the light ray direction. So that's why v is also negative. These are the sign convention for the case of a concave mirror. Okay, f is negative because it is opposite to incident light ray direction we are measuring, and uv is negative, that also measured opposite to the direction. V is also negative because we are taking the distance measured is in the opposite direction of the incident light ray. That is rule 2. Now rule 3 tells, for suppose if you are taking the distance, any of the distance, if you are measuring above the principal axis, like the height of the object, okay, that is taken as a positive. If you are taking the image position, which is like here in this case inverted images, the distance if you are measuring below the principal axis, that we are taking that as a negative. Okay, above the principal axis positive, below the principal axis that is taken as negative. That is our third rule here. Okay, these are the 3 rules we are following in case of this mirror formula. And the same if you are applying for the convex mirror, if you see the sign convention here for convex mirror. Okay, now here for a convex mirror, we already know that it is having a virtual focus we are having. And if object is placed before that, actually we are getting the image which is behind the mirror, because that is a virtual image we are getting that. So if you are taking the rule 1, according to rule 1, all distances we have to measure starting from the pole. So that's why the object distance from pole to the object, u is the object distance, and whereas starting from the pole to the focus, that is the focal length, and starting from the pole to the image, that we call that as image distance v. So u, v and f, these are our distances there. Okay. Now if you are taking again the incident light ray in case of this convex mirror case, then what happens there is, if you observe the focal length and the incident ray, both are measured in the same direction here. Means the distance we are measuring from the pole to the focus is as the same direction as incident light ray. That's why here focal length is positive. Okay, and in the same way here if you are taking for the case of this object distance is measured opposite to the incident light ray here. So that's why u is negative. Okay, whereas in case of v, if you are taking the image distance, it is taken in the direction of incident ray, as both are in the same direction, then v is also positive here, like this. F is positive, u is negative, and v is positive in case of convex mirror. Okay, and this is for concave mirror. Now we got the mirror formula there, and we got the sign conventions of which we have to apply for our mirror formula also we got. Now we are ready to do the problems on this mirror formula here. Let us start with a very simple and easy one, so that we are having a concave mirror having a focal length, let us suppose 10 centimeters. Okay, and here we are using a concave mirror, that is a concave mirror. Now as the focal length is given as 10 centimeters, let us suppose the object distance here it is given, let us suppose 15 centimeters. Okay, then what to find there is, what about the image position? Okay, we have to find the image position. Only 2 steps here we have to follow. So that first one is, at first after taking the formula 1 by f is equal to, this is the solution, 1 by f is equal to 1 by v plus 1 by u. Then focal length value is given, directly substitute the given values there. Focal length is 10 and image distance we don't know, whereas object distance is 15 centimeters is already given here. So we got 1 by 10 is equal to 1 by v plus 1 by 15. Now if you apply the sign convention, we know that if it is a concave mirror, the focal length of concave mirror is minus. So that's why here we have to take minus 1 by 10 is equal to, for the case of v, image distance, we don't know any value about that image distance. So that's why you need not to apply sign convention for v. Then don't directly go to the object distance here. As we know the object distance here, then if you apply the sign convention for object distance, for concave mirror, the sign convention is a negative, which is minus, that is like this. Then finally you'll get minus 1 by 10 is equal to 1 by v minus 1 by 15, that is. Okay. Then what we need is 1 by v value we need. So bring that 1 by 15 this side. Then minus becomes plus 1 by 15 minus 1 by 10 is equal to 1 by v, that is. Then the image distance 1 by v is equal to, if you are taking 1 by 15 minus 1 by 10, then if you take LCM 15 and 10 there, okay, so that you will get 30, 15 twos and 10 threes. So that you will get minus 1 by 30, that is, which is 1 by V value this is. Then V becomes minus 30 centimeters, like this. As we have the image distance, actually for the case of concave mirror, the image distance is negative. That's why here the image distance we are getting V value as a negative, and how much that is minus 30 centimeters, that is. Okay. Now see that again. So what we have to do is only two things. First, after writing the formula, first simply substitute the given values. As in the given problem, focal length is 10, image distance we don't know, object distance U is given as 15, we substituted that. That is a step 1. Step 2 is here apply sign convention only for the given values there. Don't apply sign convention for unknown values like V in this problem. Okay. Then if you apply the sign convention, 1 by 10 minus and 1 by V minus 1 by 15. If you solve that, again we are getting the sign convention back here. So that for the case of image distance, as it is minus for concave mirror, that's why we are getting V is equal to minus 30 centimeters. But after completing the problem, once again we have to check about our ray diagram. Is our answer correct or not? By the verification of ray diagram, we can check that. For example, in this problem only, as focal length is 10, then its center of curvature position becomes 20 centimeters, that is C value. And F is at 10, C is at 20. Then object distance UV is 15, means that object is placed in between C and F, that is, this is F, it is C, then object is placed in between C and F, that is. As the object is in between C and F, then the image has to form in between C and infinite, that is. That's why here we got, as the image distance is the 30 centimeters, 30 centimeters is more than the center of curvature position distance, that is, which is more than 20. That's why here the image is formed in between C and infinite. So that's why here, even by using ray diagram also, we can verify our answer. Now, let us suppose just like the concave mirror, now we will check this mirror formula for the case of convex mirror. But if you are taking the same positions there, so that object is placed at 15 centimeters before a convex lens having focal length of 10 centimeters, same problem, but if you replace that concave mirror with a convex mirror this time. So this is about convex mirror we are taking. Then as UV is 15 and focal length is 10 centimeters and we need the image distance, and again as the formula is 1 by F is equal to 1 by V plus 1 by U, then focal length it is of 10 centimeters, image distance we don't know, but object distance given is 15 centimeters, that is. And that it is a convex mirror, then the sign convention if you are taking the focal length, sign convention for convex mirror, it is a positive. And whereas object distance if you are taking, object distance for the case of convex mirror is negative, and for the case of image distance we need not to apply any sign convention because we don't know its value. Then 1 by 10 is equal to, finally we got 1 by V minus 1 by 15. Then bring that 1 by 15 this side, then 1 by 10 plus 1 by 15 is equal to 1 by V, that is. Then 1 by V is equal to, again 10 and 15 LCM 30, then 3 plus 2 it becomes 5 by 30, which is 6. Then V is equal to, we are getting 6 centimeters, like this. And that here we got the image distance is positive sign, we are getting that, which is our convex mirror sign convention, which is for image distance it is positive. That's why here also we are getting the image distance as a positive. Now we will see another model here. So that here in this case we know that if you are placing an object before a concave mirror, about a concave mirror, an object we are taking at a distance 20 centimeters, that is, before a concave mirror, that is. Then we got here, let us suppose the image it is forming at, let us suppose 30 centimeters, that is. The image is formed at 30 centimeters. Then what we have to find is F we have to find, which is about our focal length of the concave mirror we want. Then again if you are using that mirror formula there, 1 by f is equal to 1 by v plus 1 by u. Focal length is given there, which is of, we have to find the focal length, and v is given there 30, u is given there 20, that is. Then if you apply the sign convention for concave, this is a concave mirror. Then if you are applying sign convention for this concave mirror, focal length, as we don't know the value, no need to apply. And for image distance, which is of negative minus 30, and object distance is also minus there. Then finally we got 1 by f is equal to minus 1 by 30 minus 1 by 20, that is. Okay. Then if you are taking LCM to 30 and 20 there, if you are taking LCM to 30 and 20 there, as 30 and 20, it is about 60 is the LCM. Then 30 minus 2 there and 23 is there. Then that is 1 by f. Then 1 by f is minus 5 by 60. Then we got 1 by f is equal to minus 1 by 12 and f is equal to minus 12 centimeters. This is the focal length we got. Okay, f is equal to minus 12 centimeters. As it is a concave mirror, that's why we are getting the focal length is minus 12 centimeters. Okay, now see that again. So as 1 by f equal to 1 by v plus 1 by u, we are following step 1, just substituting the values of v there 30, u there 20. And here if you are applying the sign convention for unknown values, you need not to apply the sign convention. And for image distance, which is having minus for the concave mirror, and object distance also minus for concave mirror, that's why minus 30 and minus 20 we have. So then 1 by f is equal to minus 1 by 30 and minus 1 by 20. Then 1 by f is minus 2 minus 3 by 60. Then 1 by f is minus 1 by 12. Then f is equal to minus 12 centimeters, that is. Now see another problem. Here given that if the focal length of a convex mirror is 15 centimeters, an object is placed at center of curvature of the mirror. Calculate the distance between the object and image formed. Before starting the problem, here we already know that convex mirror forms virtual image, whereas virtual image means the image is formed behind the mirror. Okay, for example, if this is the convex mirror and if you are taking the object before that, the image is formed behind the mirror there. Okay, this is the object and this is the image. And what we need is the distance between the object and the mirror we want, object and the image we want. Okay, now if you take the focal length already given 15 centimeters and object distance is given as center of curvature position. If focal length, which is the focus position, is at 15, then center of curvature becomes twice that one. Then it becomes 30 centimeters. So object is at 30 centimeters here. Then what we need is the image distance. Then as 1 by f is equal to 1 by v minus 1 by u, 1 by v plus 1 by u. Then 1 by f, focal length given 15, image distance we don't know, but object distance is given as 30 centimeters, that is. Then if you apply the sign convention, as focal length for convex mirror as it is positive, and we are finding for the case of image, then object distance is given 30. So sign convention for object distance is minus. Then 1 by 15 is equal to 1 by v minus 1 by 30, that is. If you bring that minus this side, then 1 by 15 minus becomes plus, 1 by 30 is equal to 1 by v, that is. Then finally we got 1 by v is equal to 1 by 15 plus 1 by 30, that is. Then 15 and 30, if you take LCM 30, this is of 2 plus 1, that is, which is 3 by 30. Then finally we got the image distance as positive, and that too we got 10 centimeters. Means as we are getting object distance is a positive, that image distance is positive, means the image is formed behind the mirror. And according to the definition of image distance, then it is at a distance 10 centimeters from the mirror. And we already know that object is at a distance 30 centimeters from the mirror. Then the distance between object and image, which is distance between image and object, is here 10 centimeters plus here 30 centimeters. Total it becomes 40 centimeters. That is the distance between image and object. Okay, now I have understood now. Now see the next one. If the radius of curvature of a concave mirror is 20 centimeters, an object is placed at 20 centimeters before the mirror, then find the magnitude of the image formed. Okay. Now here the radius of curvature is given, then r is equal to 20 centimeters is given. If r is equal to 20 centimeters, then we know that as r is equal to 2f, then f becomes 10 centimeters, that is. Now we got the focal length for our concave mirror, then object distance is also given. Our focal length is 10, object distance given which is at 20 centimeters. Now again we have to find the image distance here. Then 1 by f is equal to 1 by v plus 1 by u. Then 1 by v we don't know, and u is given 20 centimeters and focal length also given 10 centimeters. As we are using a concave mirror here, then we are getting here the focal length as negative, object distance also negative. Then minus 1 by 10 is equal to 1 by v into minus 1 by 20, that is. Then 1 by v is equal to, bring this minus 20 this side, then it becomes plus 1 by 20 minus 1 by 10, that is. Then 10 and 20, if you take LCM here, then 1 minus 2 will get, of which 1 by v, which is equal to minus 1 by 20. Then v is equal to minus 20 centimeters, that is. As v is equal to minus 20 centimeters, but the 20 centimeters is nothing but our radius of curvature position. If you remember our ray diagram, if the object is placed at center of curvature, the image is also formed exactly at the center of curvature. That's why we got here 20 centimeters. And not only that, if you see here, v we are getting as a negative, minus, means the image is formed again before the mirror. But here what we need is magnification factor we want. What is the magnification here? Then if you want to find magnification, m is equal to, formula is height of the image by height of object is equal to minus v by u, because this is forming a real image. Okay. Then if m is equal to minus of, as the height of image and height of object is not given, but we know the image distance, that is of object distance, is 20 and u is given as 10 there, that is of 20 centimeters, that is. Then 20 and 20 get cancelled and finally we are getting minus 1. If m is equal to minus 1, then minus represents the image which is formed is an inverted image, because magnification minus means the distance which we are measuring is below the principal axis, which is considered as inverted, and 1 represents the size, which means same size as object. So finally, as we are getting m equal to minus 1 means the image formed by this position, which is of 20 centimeters before the concave mirror, forms a same size image, and not only that, it is an inverted image. Okay, this is about the center of curvature position for a given concave mirror. See the next model here. If a 2 centimeters object is placed at 15 centimeters before a convex mirror, a focal length 15 centimeters, what is the size of the image formed? Here we are having a new thing we got, that is about the height of the object is also given in this problem. Okay, so we have to again find the magnification here. But in the given data there, the focal length is 15 centimeters for convex mirror and object distance is also at 15 centimeters here. Okay, then first we have to find the image distance, which is v here. Then 1 by f is equal to, as it is 1 by v plus 1 by u. Then focal length already given there 15 and v we don't know, and u is 15, that is. If you apply the sign convention, as it is a convex mirror, focal length is a positive, whereas object distance we have to take that as a negative. Then 1 by 15 is equal to 1 by v, and plus into minus becomes minus 1 by 15. Then 1 by v is equal to, if you bring this minus this side, then becomes plus. Then 1 by 15 plus 1 by 15. Then if you add that 1 by 15 plus 1 by 15, it becomes 2 by 15, that is. Then v is equal to 15 by 2 centimeters, which means v is equal to 7.5 centimeters. That is the image distance we got. And not only that, if you see the sign convention for the image distance, that is of having positive is there, which is like convex mirror. Okay. Now we need to find a magnification here. We know that magnification m is equal to height of the image by height of object, and it is also equal to minus v by u, that is. Then m is equal to height of the image, which is we don't know, we have to find that, by height of object, which is already given 2 centimeters, is equal to minus of image distance we got 7.5 centimeters by object distance, which is given as 15 centimeters there. Then if you apply sign convention, then it becomes minus 15. Then this minus and minus get cancelled. And earlier before also I said, if you are taking a virtual image, as the image formed by convex mirror is a virtual image, here the magnification value we are getting is a positive value we are getting here. Then height of the image by 2 centimeters is equal to 7.5 by 2, which is 7.5 ones and 2's here, is equal to 1 by 2. Then height of the image is equal to 2 centimeters by 2, of which we will get 1 centimeter. And here we got the height of the image is 1 centimeters, whereas the height of the object is 2 centimeters, which means here we are getting a diminished image we are getting. There is a decrease in the size of the image we are getting, which means the magnification is less than 1 we are getting, if you see, because m value here we are getting minus 1 by 2, that is, which value is less than 1. As m value is less than 1, we are getting a diminished image, which is less than the size of the object, which is equal to 1 centimeters. As the object size, it is of 2 centimeters size, that is. Now see one more question and different model. If magnification of image formed by the concave mirror is minus 2, when an object placed at a distance 20 centimeters before the mirror, then what is the image distance and focal length of the given mirror? If you clearly observe that here, the magnification of the image formed by concave mirror is already given. The magnification factor is given. M is equal to minus 2 is there. If m is equal to minus 2, before also I said minus represents inverted, that is, and 2 represents, that is, a magnified image or enlarged image, because m value is greater than 1. First we have to check that. M value here is more than 1, which is a enlarged image we are getting. And not only that, we know that m is equal to minus v by u. Okay? Then if m is equal to minus 2, then minus of v by, here u value is already given in the problem, which is of 20 is given. Then minus get cancelled, then v is equal to, we got 40 centimeters, that is. Means finally we got object is equal to, object distance is equal to 20 centimeters, whereas image distance we got 40 centimeters, that is. And what we need is, we need the focal length of the given mirror, f value we want. Okay. So make sure that when the magnification is given, whether it is inverted or not, and in which case of magnification, that is, of which magnification in this case, as it is 2, which means greater than 1, which is an enlarged image, that is. Okay. Then if you find the focal length here, again we have to use focal mirror formula. 1 by f is equal to 1 by v plus 1 by u, whereas 1 by focal length we don't know, and image distance here, which is 40, object distance here it is 20, that is. Then 1 by 40 plus 1 by 20, if you apply the sign convention, as this is concave mirror object distance is minus, image distance also minus. Then here minus 1 by 40, minus 1 by 20. Then minus 40 and 20, LCM again, 40 minus 1 minus 2, which is minus 3 by 40. This is 1 by f. Then f becomes minus 40 by 3, that is, which is equal to minus 13.33 centimeters. So this is what we got the focal length for the given concave mirror. And if you observe here about that ray diagram of that, focus is at minus 13.33, which is 13.33 centimeters, whereas the object is at 20. Then if a focus is at 13 centimeters approximate, means the image is going to be at 26.66, that center of curvature is at 26.66, means the object is in between U20 and this one, this is of 26.66, means that is in between focus and center of curvature. As the object is in between focus of center of curvature, the image is formed beyond the C, which is more than 26.66 centimeters, which is equal to, we got 40 centimeters. Now see here the next model. A converging mirror forms a real image of height 4 centimeters of an object of height 1 centimeter placed 20 centimeters away from the mirror. Then what we have to find is calculate the image distance and what is the focal length of the mirror. But if you see here, clearly mentioned that is a converging mirror. Converging mirror means nothing but a concave mirror. And not only that, another important thing, if you see here, it forms a real image. Real image is formed only by concave mirror, but not the convex mirror. So obviously this problem is about a concave mirror, because it is forming a converging as well as it is forming a real image, that is. Okay, so that is our first conclusion here. And here in the given problem, height of the image is given, which is of 4 centimeters is there, and height of the object is there, which is of 1 centimeter is given there. Okay, then object distance is also given, which is equal to 20 centimeters, that is, and we don't know anything about the image distance and the focal length. Then how to find that is, as we know that magnification factor m is equal to height of the image by height of object, which is equal to minus v by u. Then height of the image, which is 4 centimeters, and height of object, which is 1 centimeters, is equal to v, we don't know, whereas u value given there 20 centimeters, that is. Then v is equal to, bring this v this side, then 20 into 4, 80. Then v we got minus 80 centimeters, that is. Whereas minus represents that is forming on the same side. Okay. Now, if you are taking the case of we got v value, then u is given already 20 centimeters. Now we got 80 centimeters and we need focal length again. Then according to the mirror formula, 1 by f is equal to 1 by v plus 1 by u. Then 1 by f, we don't know f value, and v value we got 80 and u value we got 20 given. Then if you substitute the sign convention here, object distance is of negative, image distance also negative, then 1 by f is equal to minus 1 by 80 and minus 1 by 20, that is. If you take the LCM to 80 and 20, which is equal to 80, that is, then minus 1 minus 4, then f is equal to minus 5 by 80, that is. Okay. Then 5 and 16 get cancelled, then f is equal to, we got minus 16 centimeters. This is the focal length we got, f is equal to minus 16. And not only that, if you observe here, we are finding for the case of converging mirror. Converging mirror is a concave mirror, and concave mirror focal length is minus 60, minus only we have the sign convention. That's why we got f is equal to minus 16 centimeters. Okay. And not only that, here if you observe, given that it is a magnified image there, because height of the image is 4, height of object is 1, then height of image by height of object, m value is getting 4, means that is a magnified image we are getting that. If you are getting the magnified image, means the position of the image should be in between C and infinite. As focal length is 16, means focus position is at 16 centimeters, then center of curvature is at 32 centimeters. Then we are getting the image 80, means here that is beyond C, in between C and infinite. Now see the next one. When an object is placed at a distance of 60 centimeters from a convex mirror, which is a diverging mirror, the magnification produced is 1 by 2. So if you observe here, m value is less than 1. So the magnification is less than 1, means the image formed is a diminished one. Where should the object be placed to get the magnification now 1 by 3? Means we want more diminished image now. Okay, as the magnification is given again, m is equal to 1 by 2 and object distance is there 60 centimeters, means u value is also given as 60 centimeters here. Then we know that as m is equal to v by u, then m value which is 1 by 2, okay, then m is equal to 1 by 2 is equal to v by u value is given as 60. Then v becomes, then 2 ones 2 30s, then v is equal to 30 centimeters, that is. Now we got image distance which is of 30 centimeters, that is. Then from the mirror formula 1 by f is equal to 1 by v plus 1 by u, then 1 by f is equal to v value it is of given 30 there and u value is 60 there. Then according to the sign convention, object distance is minus, image distance is plus here for convex. Then 1 by f equal to 1 by 30 minus 1 by 60, which is 60 if you take LCM, then 2 minus 1, then 1 by f is equal to 1 by 60, that is. Finally we got the focal length is 60 centimeters. This is the focal length of the image formed here, focal length of the convex mirror given there. But now the question is, if you want to get the magnification instead of 1 by 2, more diminished m is equal to 1 by 3, then where the object has to be placed? Then if m is equal to 1 by 3, then we know that again as m is v by u is equal to 1 by 3, then u is equal to 3v, or v is equal to u by 3 we have to take. Okay, then we know that 1 by f is equal to 1 by v plus 1 by u, then 1 by f value, where f is given, f we got the value 60 centimeters is equal to v value we got 1 by 3 u by 3, that is, plus u, that is. Okay, u by 3 and u, that is. Then if you take u, so if you apply the sign convention here, f it is a focal length which is positive here, but object distance is minus here. Then 1 by 60 is equal to, bring this 3 to the numerator, then 3 by u minus 1 by u, that is. Then 1 by 60 is equal to 3 by u minus 1 by u, which becomes 2 by u. If you cross multiply that, then u is equal to, we will get 120 centimeters, that is. Means if you want to get more diminished image, m is equal to 1 by 3, then object distance we have to place 120 centimeters. But if you observe here, initially the object is at 60, so the magnification is 1 by 2 here. Now the object is at 120, means the object distance is increased. Then if you observe the magnification here it is more diminished, because if the object is at 60, magnification we got is 1 by 2. If the image is at 120, or object is at 120 centimeters, the image we are getting is more less than 1 by 2, which is 1 by 3 we got. Means nothing but once you are increasing the object distance from the mirror, the size of the image is gradually decreasing up to our focus. Okay, then once you get at the focus, we are getting a highly diminished image we are getting. Now see another problem. A convex mirror used for a rear view mirror of an automobile has radius of curvature 3 meters there. If bus is located 5 meters from this mirror, find the characteristics of the image formed. Here actually rear view mirror is our convex mirror which forms a diminished image there and virtual and erect image on the mirror here. Now for that, given as the radius of curvature is given, which is of 3 meters is given, then its focal length becomes r by 2, which is 3 by 2, that is 1.5 meters. As focal length we got 1.5 meters, that bus which is acting like object here, that object is at 5 meters from the mirror there. So we got u value also there. Then we got 1 by f is equal to, according to our mirror formula, 1 by f is equal to 1 by v plus 1 by u. Then 1 by f is equal to, f value given 1.5 is equal to v 1 by v plus, and u is 5 meters given there. Okay. Then 1 by v is equal to, then if you apply the sign convention, as focal length it is of positive for convex and object distance it is of minus there. Bring that minus this side. Then 1 by 1.5 minus becomes plus 1.5 is equal to 1 by V. Then finally we got 1 by V is equal to 1 by 1.5 plus 1 by 5. 1 by 1.5 we can write that as 10 by 15 plus 1 by 5. Okay. Then if you take LCM, then 1 by V is equal to 15, 10 plus 3. Then 1 by V we got, which is of 13 by 15, or V is equal to 15 by 13 centimeters, that is. Okay. Of which V approximately it becomes, V is equal to 1 point, as it is of 30, 2 will get 1.2 centimeters. Then actually here they are asking for find the characteristics of the image formed. We can get the characteristics of the image formed. As the object distance we are getting, object distance is given as here 5 meters, and here we are getting the image as 1.2 meters. And that we got positive. As it is positive, the image formed here is a virtual image. If you find the magnification, M is equal to V by U, then V we are having 15 by 13 by object distance is 5, then 5 ones, 5 threes, then we are having magnification value 3 by 13. So as magnification value 3 by 13, which means M value is less than 1 we are getting. So if M value is less than 1, which represents that is going to be a diminished image, and not only that, M value we are having positive. If M is a positive, which means that is a virtual image is formed. Okay.